Actually, it looks like a power m minus n. And we know how to write this. A power m divided by a power n. In the same way, you can write 2 power 3 divided by 2 power log 3 base 2. Okay. So that is equal to 2 power 3. We know that it is 8. And you can exchange because logarithm was in a power place. So you can exchange the numbers. So 3 power log 2 base 2. And log a base a equal to 1. So using this property, log 2 base 2 was 1. So 8 by 3 power 1, that means the value is equal to 8 by 3. Understood this question? How I solved this? Next problem, find the value of log find the value of 7 log 16 by 15 under base 2 plus 5 log 25 by 24 log base 2 and 3 log of 81 by 80 base 2. Now, we know that how to write this. So log of 16 by 15 whole power 7 base 2. So what is the property I just performed here is, for example, m log x base a. Okay. And it can be written as log x power m base a. So the main thing, m can be, you can move that m as a power of x. And using the same property for the rest of the numbers also. So this 5 become whole power 5 base 2 plus log 81 by 80 whole power 3 base 2. Fine. Now you can see, you can use one more property in this step. If log m base a plus log n base a is there, you can write log of m into n base a. So therefore, all logarithms have same base. So log base 2 of 16, you can express this 16 as 2 power 4. Why? Because I want to express every number as a least powers. Least powers means prime powers. That is the best word you can use. Every number express as prime base numbers. So base should be prime number. Yeah, the power can be any number. 15, you can express 3 into 5. 3 is a prime number and also 5 is also prime number. 3 5s are 15. I expressed 15 as 3 into 5. And it is multiplied by, because log property, if it is connected with the plus sign, you can merge them, all those terms, as a product. Next, 25 you can write 5 square. And 24, you can write 8 threes. 8 threes means 2 cube into 3 and whole power 5 multiplied by 81 can be expressed as 3 power 4. 80 can be written as 16 fives. 16 fives means 2 power 4 into 5 whole power 3. Okay. So look at the whole powers. 7 is still same and 5 is also same and 3 is also same. I just changed the these fractions. 16 I expressed as 2 power 4. 15 3 into 5. 25 5 squares. 24 2 cube into 3. 81 3 power 4. 80 16 5. 16 again 2 power 4. Now distribute the whole power 7 for the first number. So now 4 sevens are 28 divided by 3 power 7 because it covers the each and every number on that bracket. And 5 power 2 fives are 10 divided by 2 power 3 fives are 15 into 3 power 5. And again it is 3 power 4 threes are 12 and 2 power 4 threes are 12 and 5 power 3. Now you can cancel the numbers. First I am cancelling numerator 5 power 10, 5 power 7 and 5 power 3 in the denominator. They are 5 power 10. Next I am going to cancel 3 power 12, 3 power 5, 3 power 7. Next, if you see in the denominator, 2 power 15, 2 power 12 means around 2 power 27 and 2 power 28 got cancelled. So only 1, 2 left with the base logarithm 2. So log 2 base 2, of course it is 1. This will be the answer. Next, we are going to solve one more this kind of problem. Log 17 base 4, log 23 base 9, and the second number log 17 base 2, log 23 base 3. The first number, you can write 17 power 1. Base 4 means you can write 2 squares. Whole divided by log 23. Base 9 means 3 squares. Minus log 17 base 2 divided by log 23 base 3. Now, these powers, you know the property of logarithm. If a logarithm input has some power and base is also having some power, then m by n log x base a. So therefore, 1 by 2 log 17 base 2. And again here also we apply the same property, 1 by 2 log 23 base 3 minus there is no changes in the second number. So keep that same log 23 base 3. 1 by 2 got cancelled. Now you see these numbers are looks like same. So you can cancel them. So the answer is 0. Next we will solve third problem under problem number 2. So look at how many powers you can see here. So logarithm base 2, fourth root 64, you can write 64 as 2 power 6. And next cube root 4 power 1 minus. That means you can write 4 as 2 square on the whole power minus 1, 2 power minus 2. 8 means 2 cube. 8 means 2 cube. Power minus 4 by 3. 3 cancel. So log base 2, fourth root 2 power 6 and cube root 2 power minus 2. And here after cancel this 3, we have 2 power minus 4 here. You can multiply these two numbers using the property a power m into a power n as a power m plus n. Use this property here. So minus 2 minus 4 is minus 6. So fourth root will continue fourth root under 2 power 6 and cube root. This is what 2 power minus 6. I just added the powers. And 6 and cube root got cancelled. 6 whole power 6 and cube root cancel. So fourth root 2 power 6. And how much left? 3 goes to 6 in 2 times. So 2 power minus 2. And again use the same property. So therefore it is log base 2, fourth root of 6 minus 2. 6 minus 2 is of course 4. This 4 and this fourth root cancel. So log 2 base 2. Log 2 base 2 was 1. Okay. And next, fourth problem. Log 49 can be written as 7 square. Root 7, you can write 7 power 1 by 2. Plus log 25, you can write 5 square. Here you can observe that log has no base they mentioned, means it has base 10. So 5 power root 5 means 5 power of minus log 4 means 2 square into root 2 means 2 power of whole divided by log 17.5. So therefore it is log 7 power 2 plus 1 by 2. You can add these powers plus log 5 power again 2 plus of minus log 2 power 2 plus of and with a base, divided by, of course, you can write this one as a base, 17.5. You can see the powers, log 7, this is 5 by 2. If you do LCM, 2 plus 1 by 2, 5 by 2. And log 5 power 5 by 2 minus log 2 power also 5 by 2. And whole divided by log 17.5. Now, we know that logarithm, if it has any power, suppose log x power m base a is equal to m log x base a. So using this property for the 3 numbers, the numerator, it is 5 by 2 into log 7 plus again 5 by 2 into log 5 minus 5 by 2 into log 2 and whole divided by log of 17.5. And in the numerator, every number has a common multiple 5 by 2. So considering 5 by 2 as a common coefficient, common term, so log 7 plus log 5 minus log 2 and whole divided by log of 17.5. That is equal to 5 by 2 of, you can write 7 into 5 by 2. Here I am using the property. The property is log m plus, of course, it is base a, log n base a minus log p base a. And this value is equal to, you can write mn divided by p. Okay, using that property, I got this. 7 5s are 35. 35 by 2 is 17.5 whole divided by log 17.5. So log 17.5 got cancelled. So 5 by 2 will be the answer of this question. Now you can see this problem. Here I am going to use the property. If log a base b is there, so you can write log a by log b. So the first number log a power 4 by log b power 5 multiplied by log b power 7 divided by log c power 3 multiplied by log c power 9 divided by log a power 8. And next I am using the property, if logarithm input has some power, then that power become quotient. So m log x base a. So it will be 4 log a divided by 5 log b multiplied by 7 log b divided by 3 log c, again multiplied by 9 log c divided by 8 log a. You can see log a cancel in the numerator and in the denominator. And also log b cancel, also log c cancel. And also 4 cancel in 8 2 times, 3 cancel in 9 3 times. That's it, right? So 3 7s are 21, 5 2s are 10. It will be 2.1. This will be the answer of this question. The next problem. Log x base x. So every logarithm has base x, so that you can write the inputs in multiplication, because we have log m base a plus log n base a. You can write log of m into n base a using this property, so that I can multiply x into x cube into x power 5 and so on into 2n minus 1. All are multiplication. So log base x of, so if the terms are in multiplication, like a power m into a power n equal to, you can write a power m plus n. So 1 plus 3 plus 5 plus and so on 2n minus 1. So now we are going to sum these all numbers, and the formula was sum of, 1 + 2 + 3 + 4 + 5 + 6 + 7 + 8 + 9 + 10 + 11 + 12 + 13 + 14 + 15 + 16 + 17 + 18 + 19 + 20 + 21 + 22 + 23 + 24 + 25 + 26 + 27 + 28 + 29 + 30 + 31 + 32 + 33 + 34 + 35 + 36 + 37 + 38 + 39 + 40 + 41 + 42 + 43 + 44 + 45 + 46 + 47 + 48 + 49 + 50 + 51 + 52 + 53 + 54 + 55 + 56 + 57 + 58 + 59 + 60 + 61 + 62 + 63 + 64 + 65 + 66 + 67 + 68 + 69 + 70 + 71 + 72 + 73 + 74 + 75 + 76 + 77 n odd numbers equal to n square. Sum of n odd numbers is equal to n square. I will give you examples on this statement. For example, first is important. So 1 plus 3. 1 plus 3, we are able to calculate it is 4. But of course, it is, how many numbers is there? 2 numbers. So you can write 2 square like n square. For example, if you consider from starting 1 plus 3 plus 5 plus 7, okay. So how many numbers in counting? 4 numbers, and they are from starting 1, and they are continuously odd numbers. So 4 square 16 will be the sum. In the same way, here also you can see odd numbers. So how many they are in total? They are n odd numbers. N odd numbers. So therefore, the number will be, the sum of those numbers will be n square. And I will calculate separately if you don't trust this sum. So 1 plus 3 plus 5 plus 7 plus and so on plus 2n minus 1 equal to, actually this is arithmetic progression. First number is 1 and common difference is 3 minus 1, which is 2. And we learned it in the sequence and series. And Sn, and how many numbers we need to calculate? N is equal to number of numbers, last minus first by difference plus 1. Using this formula, we will calculate how many numbers is there. So last number is 2n minus 1. First number is plus 1 divided by common difference is 2, and at last plus 1. So minus 1 plus 1 cancel, 2 got cancelled. So n plus 1 terms is there. Not n terms, n plus 1 terms totally. Okay, last minus first by difference plus 1. So we got n plus 1 numbers. So sum of n plus 1 numbers is equal to, how much it is? N plus 1 by 2, a plus l. A plus l means 1 plus 2n minus 1. So minus 1 plus 1 cancel, 2 cancel. So n of n plus 1. N of n plus 1. What is this sum of events? But it is. Okay, this is nth term they given. Nth term means n numbers is there. Not n plus 1, n numbers only. N numbers only. So therefore, the answer is n square. N numbers only, n square. So this is correct. So therefore, n square become quotient and log x base x. So that is equal to n square of log x base x is 1. So the answer is n square. Fine. This 2n minus 1 is nth term. So n numbers is there. Not it is a last number. It is nth term. Not it is last number. Next, we will solve third problem. Show that log 2 base 10, log 2 base 10 plus 7 log 81 by 80 base 10 plus 12 log 25 by 24 base 10 plus 16 log 16 by 15 base 10. We have to prove that this is 1. Now we already solved this kind of problem. So log 2 base 10 plus log 81 by 80 whole power 7. Of course, it has base 10. There is no need of writing every time base 10, logarithm base 10. Just not writing. No need of writing this. Okay. So plus log 16 by 15 whole power 16. Now log 2 plus log 81 can be written as 3 power 4 by 80 can be written as 16 5. 16 5 means 2 power 4 into 5 whole power 7 plus log 25 as 5 square. 8 threes means 2 cube into 3. So every number I'm going to express as a prime basis. So log 2 power 4 and this is what 3 into 5 whole power 16. So therefore so log base 2 plus and you can apply the whole power 7. So okay, shall we merge all these numbers together? That's better, best idea. How much time we can wait for this? So we know that this property is log m. If the logarithms are in addition, you can multiply them together. So log of 2 into, so 3 power 4 sevens are 28 divided by 4 sevens are 28 into 5 power 7. Okay, along with I distributed the whole power also. So 5 power 2 twelves are 24 divided by 2 power 3 twelves are 36 and 3 power 12 and again multiplied by 2 power 16 fours are 64 and 3 power 16 and 5 power 16. Now you can see 5 power 7 and 5 power 16. It is 23, 24 in the numerator. So we have one more 5. One more 5 left after calculation in the numerator. And you can see 3 power 16 and 3 power 12 means totally 3 power 28 cancel. And also 36 and 28, 64 cancel. So finally, log 2 into 5, log 2 into 5, log 10. Log 10, of course, it is base 10. So the answer is 1. And next, fourth problem. So if e power f of x equal to 1 plus x by 1 minus x and k into f of 2x by 1 plus x square equal to f of x. This was given. Fine. So what should we do here? So we will take log on both sides. Take log on both sides. So log e power f of x is equal to log of 1 plus x by 1 minus x. And we know that it is log base c. And we know that power become quotient. So f of x into log e base c. Log e base c is 1. And there is no need of writing every time logarithm base c. So log a base c is 1. So therefore, we have the definition. F of x is equal to log of 1 plus x by 1 minus x. So understand it properly, f of x definition. If x is there along with f as an input, x is there, then log of 1 plus that input and divided by 1 minus that input. You have to represent f of x like this one, log of 1 plus x by 1 minus x. If you see here f of 2x by 1 plus x squares, then how can you express this? So log of, right? F means log of 1 plus, what is the input? Entire input you should write. So 2x by 1 plus x square divided by 1 minus 2x by 1 plus x square. So this entire input we should write like x. And on the other hand, it is f of x. F of x means we know log of 1 plus x by 1 minus is a direct definition. Now k times of log of, if you perform LCM, simple LCM, 1 plus x square plus 2x, and denominators got cancelled, 1 plus x square minus 2x is equal to log of 1 plus x by 1 minus x. So k into log of, here you can write 1 plus x whole square divided by, in the denominator, you can write 1 minus x whole square equal to log of 1 plus x by 1 minus x. Both of these whole squares, you can mention 1 plus x by 1 minus x whole square equal to log of 1 plus the right side. There is no changes in the right side. And this 2 is a whole power of this logarithm input. So the power become quotient. So 2k into log of 1 plus x by 1 minus x is equal to log of 1 plus x by 1 minus x. So log of 1 plus x by 1 minus both sides it getting cancelled. So 2k is equal to 1 and k is equal to 1 by 2. So therefore the value of k is 1 by 2.